Ever pondered the complexity of decision-making in games? Why do players often make choices that seem counterintuitive? Decision-making in games is a fascinating labyrinth, often more intricate than it appears on the surface. It's not just about making the best choice. It's about predicting and reacting to the strategies of others. Every move, every choice, is a delicate dance of strategy and foresight. Enter the world of game theory, a fascinating field of study that delves into strategic decision-making. Imagine two prisoners, each faced with a choice: betray the other or remain silent. Their fate hinges not only on their own decision but also on the others. Each prisoner finds themselves in a tricky situation. They can either choose to betray their fellow prisoner or they can choose to stay silent. But here's where it gets interesting. If both prisoners stay silent, they both get a light sentence. However, if one betrays the other while the other remains silent, the betrayer walks free while the silent one gets a heavy sentence. If both betray each other, they both receive a moderate sentence. Here lies the dilemma. The best individual choice, betraying the other, leads to a moderate sentence for both. However, the best collective choice, remaining silent, leads to a lighter sentence for both. Yet the fear of the other betraying leads both to choose betrayal. This predicament encapsulates the essence of the Nash Equilibrium. So, what does this prisoner's dilemma teach us about the Nash Equilibrium? Well, think of it this way. Our two prisoners find themselves in a tricky situation. They're each faced with a choice: betray the other or remain silent. Now here's where it gets interesting. Their decision isn't just about their own actions, but also hinges on what the other does. This is where the Nash Equilibrium comes into play. It's a concept named after the mathematician John Nash that represents a situation where no player can improve their outcome by unilaterally changing their strategy, provided the other players keep their strategies unchanged. So in our prisoner's dilemma, the Nash Equilibrium happens to be when both prisoners betray each other. Why? Because given the other person's decision to betray, each prisoner can't improve their outcome by changing their strategy. Betrayal is their best response to the other's strategy. But here's the twist. Even though betrayal is the Nash Equilibrium, it leads to a worse overall outcome than if both prisoners had chosen to remain silent. That's the paradox of the Nash Equilibrium. It doesn't always result in the best collective outcome, but only the best individual response to a given set of strategies. The Nash Equilibrium, a cornerstone of game theory, provides a lens to understand complex behaviors in competitive and cooperative situations. It helps us analyze how individuals and organizations can optimize their strategies in uncertain and interdependent environments.